So the model we're going to use for a logarithmic regression is y equals a plus b natural log of x. And we're going to remember that the domain for our x values has to be greater than 0, so 0 to infinity. What else do we want to remember? The graph will go through the point 1 comma a. Yeah, okay. And let's see, what else do we want to know? Oh, if b is greater than 0, then it's going to be an increasing function. So it's going to look like, something like this. Something like that. If b is less than 0, then it's going to be decreasing, and the model looks something like this. Okay? All right, so that's just a review of a linear function. Now let's look at this problem. Due to advances in medicine and higher standards of living, life expectancy has been increasing in most developed countries since the beginning of the 20th century. And they give us this table of year and life expectancy. All right, let x represent time in decades. Okay, so we're going to be going every 10 years, starting with x equals 1. So we're going to say in 1900, x equals 1 for the year 1900. Okay, so 1 for 1900, 2 for 1910, and so on. Now this is important because of our model and our x values. So we have 12 data points again, and now we want to graph these. And so we're going to have something, and we'll go, let's see, 2, 4, 6, 8, 10, 12. Okay. And you can fill in the little marks in between. That might be helpful. Okay, I probably could have made it a little bit bigger. And then life expectancy, what are we going from? It looks like they're increasing, right? And we're starting at about 47.3 and going up to close to 80. So what do we want to count by? Let's just count by tens. 10, 20, 30, 40, 50, 60, 70, 80. All right. Kind of similar to the last one. And this is life expectancy on this axis. And this is, well, it's the x value in our model. Yeah, we'll just label it x. Okay, it's representing, though, the year, the decade after 1900. So that's a little bit tricky. So we'll just let it be x for the labeling purposes. Okay, now we want to graph these ordered pairs. So in 1900, the life expectancy was almost 50, so it's up there. Oh, and that's at 1. Sorry, not at 0. This is going to be hard to erase, but I'll try to squeeze it. Okay, good. And so that's at 1, almost 50 years old. And then in the second decade, or in the first decade after 1900, which is going to be 0.2, it was 50. And then 3 is 54, maybe there. 4 was almost 60. That should be back a little bit. 5 was 62, a little bit higher. And 6 was almost 70. And 7 was closer to 70, I guess. Kind of starting to level off a little bit. And then 8 was just over 70. Really see this leveling up. 9 was 73, so a little bit higher. 10 was 75. I think I have them a little too high. 11 was a little bit higher, but not much. And then 12 was just a little bit higher. A little hard to see that as a logarithmic curve, but it's going like this, basically. Okay? So on a piece of graph paper, maybe I could have a little bit better graph, but it's looking like that. The model is found using a graphing calculator, but we're just going to use the model that they have. Now here's the tricky part. It says use the model to predict the average American life expectancy for the year 2030. We have to go back and say, when is 2030? Well, 2010 was a 12, so 2000, remember going by decades, 2020 is going to be 13, 2030, x will be 14. So we want to say x is 14. So you're going to put all of this in, 42.527222583. You have to type it all in your calculator, plus 13.85752327, you and your calculator, and then a natural log of 14. And you put that all in, stop the video and you put that all in. My calculator gave me about 79.098. I'm going to round that off to the nearest tenth and have 79.1. Okay.